screen? Screen is okay for everyone? Hello?
Yes, sir.
Yeah. I think yesterday we are doing a problem of first order logic, okay? And we discussed this problem, okay? The perfect square example we have completed yesterday, okay? And we are in the discussion of harm clauses, okay? Let me discuss about 2 minutes about harm clauses, and let me go to resolution topic in first order logic, okay? Now, if you want to write a resolution topic, first what you have to do is you should convert your sentences into conjunction normal forms. Is it okay? Here, if you observe this sentence carefully, this is nothing but one atomic sentence. Perfect square of 36 is one atomic sentence. Is it okay? Is it visible for everyone? Here you are observing that perfect square is underscore 36 is one atomic sentence. Now we cannot call it a sentence, we can call it as atomics. Okay, atoms. Okay. Then if you combine several kind of atoms, okay, at left side, implies if you have a right side a single atom, that is nothing but Horn sentences. Now observe carefully. What is the rule for Horn sentences? Implication with the conjunction of atomic sentences. Observe carefully. In this example, this is one atomic sentence, okay, and this is another atomic sentence. Prime y is another atomic sentence, and divide y is another atomic sentence. Now, if I combine these atomic sentences in the form of conjunction, okay, if I combine these atomic sentences in the form of conjunction, now with implication, please, at left side, with implication at left side, and right side if you have only one atomic sentence, okay, that is called as Hahn sentences principle, okay. I already told you that you can have universal quantifier. You can have universal quantifier, but you cannot have there exist or existential quantifier in Hahn sentences. If it is okay, I will start my topic. Shall I go? Is it okay for everyone? What is the principle of Hahn sentences? Left side you have conjunction of atomic sentences with implication, and right side you will have only one atomic sentence, okay, and you should convert your FOL logic into Hahn sentences before going to resolution. Is it okay for everyone? Hello? Hello? Hello?
Yes, sir.
Is it okay for everyone?
Yes, sir. Okay, sir.
Sir.
Now, what we will do? Now, I have told you what are the rules for converting FOL into Hahn sentences. Okay, there are two rules. Whenever there are existential quantifiers, before sentence I told you that you may have universal quantifiers, but you cannot have existential quantifiers. If you have any existential quantifiers in your FOL, what you should use is you should use either a incorporation of Skolem constant or incorporation of Skolem function. Okay, in this example, by removing existential quantifier of there exists y, okay, wherever y is there I can replace with the p. Okay, now where p is a Skolem constant, this is rule number 1. Otherwise you can replace y with any function. Here pd of x is called as function, okay, here it is called as Skolem function. Now, but by using either a single constant p or by incorporating a function, we should convert their exist symbol into Skolemization. The process of conversion sentences into Hahn sentences. Okay. Now, these are the two rules. Now, one more important rule is and elimination. Okay. Now, how can you eliminate and sentences? There is no need to eliminate any sentence. Left side you have one atomic sentence, and right side you have one atomic sentence. Okay. If you separate those sentences, Now here I have separated one sentence as prime P and another sentence as X of P. That itself means nothing but you have eliminated the and sentences. Now, if you have these basic knowledge, then I can start what is resolution, okay, in today's class. Now, can anyone tell me what is resolution principle? Hello? Please give me 1 minute. I will try to share one document. Can anyone tell me what is the principle of resolution in first order logic? What principle we discussed? New slide. I have opened the slide. Let me open. Slide is okay for everyone. Is it visible? Hello? No. Can I write it here? No. No. Can I tell? Can I write it here? What is the resolution principle? What is the resolution principle? Please, I need information from you. Resolution. If I know this principle, then I can move. Okay. I told you that X is a literal. Observe carefully, and I have string 1. Okay. And negation of X or string S2. Okay. Which gives me sentence 1 or sentence 2. Did we discuss the same as the resolution principle in first order logic? Yes or no? Hello?
Yes, sir.
Now, could you please open your notebooks and observe whether the principle is same or not for resolution? The same principle we are going to apply first order logic also. Kindly check it once and tell me. I will wait for 1 minute. No hurry for me. Now, this example you have to solve by yourself. Okay, I will tell you the guidelines. I will be like a guide for this example, please. Several examples I am doing from my side. You are not doing anything, please. Is it the resolution principle? Yes or no?
Yes, sir, it is.
Now, yes, no. If so, let me give 1 minute. Let me close this PPT and share that PDF. Yeah, give me 1 minute. Yeah, first note down the problem. Then we will try to solve step by step. Okay. Sorry, I have forgotten to discuss another very important topic called as substitution and unification. After that only we will get a problem. Okay, the problem we will get here. Okay, please let me introduce a new topic called as substitution and unification. Okay, unification I will discuss more in the next week. It will take 2 full hours. Okay, now I am introducing the concept. Okay. Now, what is the meaning of substitution? Substitution means replacing a variable with constant. Same thing, we are doing the same thing in existing universal elimination. Yeah, are we doing the same thing? Hello? Hello?
Yes, sir.
Now in the same thing we have done it in universal elimination for all X. How we have eliminated where the variable was replaced with constant. Will you agree? The process itself is called a substitution. Okay. The process of replacing a variable with a constant is called a substitution. Is it okay?
Yes, sir.
Now, look at this. Now, I have this. For that, we have written a simple function as subst. This is our function. Okay. Now, here, what we are substituting is x by 49. Please observe carefully. X by 49, then perfect square of x. Now here I am substituting x with 49. Now shall I call this sentence as perfect square of 49? Hello? If I substitute x with 49, please observe, if I substitute x with 49, can I call perfect square of 49? Yes or no?
Sir. Yes, sir.
Now, if you observe the same thing, what about the first statement of our previous example? If a prime is divisible by x, now 49 is a prime square. Now we are taking a prime called 7. Now 7 is divisible by 49. Will you agree? Now x is 49 and y is 7. Now 7 is divided by 49. Will you agree this statement where x is 49 and y is 7? Now can I call it as 7 is a prime which divides perfect square of 49? Yes or no?
Yes, sir.
This process this process we are calling them as substitution. Okay, you already know it. No need to, but you should know the name. Now, the original name for that substitution is unification, please. That I'm not going in depth of unification, but in the next week I'll take full 2 hours classes on this topic itself. Okay. What is the meaning of unification? Unification is the process of finding substitute. Very, very important point. Please observe carefully. Unification is the process of finding a substitution that makes two atomic sentences identical. For example, please. For example, if I have now in the previous example also we had done same thing. Now let me discuss with this. Can anyone tell me what we have done it here, please? Is it how I got this statement? Divides of 36 comma square of p. Can anyone tell me? Whatever the fifth statement is there, now I'm saying that fifth statement is exactly same as first statement. Observe carefully. Fifth statement is exactly same as first statement. So wherever the first statement comes, I'm replacing with the divides of x by 36. Is it okay? Will you agree about it? Now, instead of writing perfect square of 36 and prime of p divides of 36 comma p, I am writing as divides of 36 square of p. Yes or no here? Yes. This process itself, now replacing one atom, please observe carefully, replacing one atom with the equivalent atomic sentence is called as unification. Is it okay? Hello? No, you got it? Hello? Now, shall I go to the definition? Understood? Shall I go to the definition? Yes. Observe carefully. Unification is the process of finding a substitution that makes two atomic sentences are identical. In the previous example also, we have replaced one atomic sentence with another sentence. The process itself is known as unification. For that, you should follow so many rules. Okay. For that, you should follow so many rules. Okay. Now, I'm writing a simple rule. Unify is our function. It is not a built-in function. It is our own written. Unify. You can write your own name also. Here, what we have written is prime of 7, prime of x. Now, can I call x is replacing 7? Hello. Now, wherever this atomic sentence comes, can I replace with x by 7? Hello?
Yes, sir.
Now, observe carefully. Here, what we are doing is prime of 7 with the prime of x. Now, I can replace x by 7. Is it okay? This process is known as unification, but I will discuss the rules, the unification process, everything in the next class. Okay? Because why I am saying, because in the process of solving examples, we are replacing one atomic sentence with another atomic sentence. Okay, you should know the name. For the purpose, I'm introducing this point. Is it okay? Unification is nothing but process of finding a substitution that makes two atomic sentences are identical. That means wherever you find a same sentence, same atomic sentence, you can replace it. The same thing which you had done in the earlier example. Shall we go? Now, shall we start the problem of resolution with these principles? I'm going to start a problem. Now, everybody, please open your notebooks. Please open your notebooks and write these sentences. Okay, we have 4 sentences. The first 3 are sentences which are given by the problem, and last sentence is to be proved. Okay, please take the first sentence as S1, second sentence as S2, and third sentence as S3. Shall I explain first? Shall I explain? Now, the first sentence is all people who are graduating are happy. Is it exactly same as your yesterday's principle? All philosopher will write a book, at least one book. Is it okay? Hello?
Yes, sir.
Now, the first sentence what they have given it is all people who are graduating are happy. I don't know whether they are happy or not. Okay, as per the sentence, we should follow it. Okay, then second sentence is all happy people smile. Second sentence is all happy people smile. Third one is someone is graduating. Okay, here someone is graduating. Are you getting me? Now we should convert these three sentences into FOL first. Now, what we have to prove is someone smiling. From these set of three sentences, we should prove that is someone is smiling using a technique called as regulation. Please take the problem. We will try to solve one by one, step by step. Are you getting me? Please take the problem. We will solve step by step. Is it okay?
Okay, sir.
Yeah, please take the problem and we will try to solve one by one. The problem will take around 15 to 20 minutes. Later, we will try to write an algorithm for resolution in predicate calculus or first order logic. Okay. Shall I move?
Just a second.
Yeah, shall I move?
Just a second, sir. We are copying.
Yes, please, no issue, please. This example we will do fully. So now, if I give any other example, will you solve it? For understanding purpose, we have taken a simple example only. Later, we will take complex examples in unification. Okay. Actually, I'm not getting highlighter. Can anyone tell me where can I get the highlighter from this PDF? P and sign. No, not this, please. Sorry. Sorry, please. Let me open it, please. Yeah, please. Is it okay?
Yes, sir. It's okay.
Yeah, please. Now, study the statement carefully for 2 minutes, please. If you want to solve the problem, study the statement carefully, okay? Then come to a conclusion. All people who are graduating are happy, okay? Now, all people, now could you please tell me any relationships did you find from statements 1, 2, 3? You please do it in your own way. Then we will start it. All people who are graduating are happy. Kindly inform me. Whether did you find any conclusions from 1 to 3 or 2 to 3 or 2 to and so on. Okay. All happy people smile. All people are graduating are happy and all happy people smile and someone is graduating. Now, did you find any relationship between those statements? Yes or no? We should prove that is someone smiling. Regulation means what we will do is we will take a negation of the statement and we will disprove it as null. Okay. Then That means yes, someone is smiling. Okay. Someone who are graduating are happy and they are going to smile. Okay. Are you getting me? Shall we prove in this way? Hello?
Yes, sir.
Yes. Yeah. First, you please take the predicates from these problem statements. What are the predicates you should consider? Okay. Graduate of x, happy of x, and smiling of x. Is it okay? Then you should convert into FOL statements. Shall we convert? Now, let me take the first statement. What is the first statement? All people who are graduating are happy. Here, he is referring all people. So, we should consider universal quantifier. Okay. Then, who are graduating X, they are happy. Okay. From this statement, who are graduating, they are happy. If you graduate it, then you will be happy. Okay. Please take the first statement. Statement by statement, we will discuss it. Please complete it. Step by step, we will complete it. Everybody are taking? Hello? Next problem you have to solve by yourself. Completed? Hello?
Completed.
Yes. Now, let us take second one. All happy people smile. Okay, here they have specified all. So it is universal quantifier. If happy, if the person is happy, then smiling of X. Please take this second statement. Third one is direct. Someone is graduating. Someone means there exists. We don't know that someone. Okay. Complete third also. Someone is graduating. That means there exists of X, graduating of X. It is a direct point. You are going to get one example either by regulation with preposition logic or regulation in predicate calculus. You may get one example in the mid as well as in the external examination. Now, shall we go for conclusion? Hello? Completed? Yes. Now, what they ask us to prove? They ask us to prove, is someone smiling? Is someone? We don't know there who is it. Okay, so we should consider this two has to prove. They exist of X, smiling of X has to be proved. Okay, is someone is smiling? Please write that within the statement to be proved. Okay, is someone is smiling to be proved. So the first order logic can be considered as there exist of X, smiling of X. Now, in the previous regulation also, we have discussed two examples. There, we have taken a negation of the symbol. Okay, what was the negation of the symbol? Negation there exists of X, smiling of X. Okay, we have taken the negative syntax of this FOL. So, if I disprove it, negation of the conclusion, and if I show it as null, that means yes, someone is smiling is correct. Else, someone is smiling is false. Are you getting me? Please take this point and write it as negation of there exists X, smiling X to be proved as null. Please make it fast. Then we'll start steps. This has to be disproved. Negation of there exists X, smiling X. If I disprove it as null, if I prove it as null, that means yes, smiling of X is somebody is smiling is true. Okay. Now, shall we start step one?
Yes, sir.
Yeah. Now, everybody is ready with it. Now, please step by step I will write. Now, for every step I will write a simple syntax Later you kindly convert them into algorithm at the end. Okay. Now the first step is, please note down the first step. Elimination of implication. Please write it as elimination of implication. As we already know that directly we have done it. How to eliminate the implication from the statement from? How to eliminate the implication? Could you please tell me? Here, it is P implication of X. This can be written as negation of happy X or smiley of X. Is it okay? Hello? Can I convert this into implication can be converted into negation of happy of X or smiling of X? Can I do or not?
Yes,
Hello?
sir.
Here, directly we have done it. Okay? Directly we have done it. Negation of graduating of X, negation of happy of X or happy of X. Clear? Now, second statement. Do the second statement. Sorry. This is second statement. Sorry. We have one more statement. Here we should have negation of graduating of X or happy of X. First, we convert these two statements into elimination of implication. Please do it. That is the first step. Okay, please. Directly we have written the two steps. This now I will call them as equation 1 and equation 2. Completed? You have to write the formula. Wherever you are elimination of implication, write the formula as negation of P or Q. Please write it as formula. If you want to elimination of implication, you should use negation of P or Q. Are you writing? Hello?
Yes, sir, we're ready.
Yes, please. And step 3, it is a direct, okay? No need to write, no, we don't have any implications, okay? Step 4 is also, there are no implications. So I can directly take them as 1, 2, 3, 4 as, you please write them as equation 1, equation 2, equation 3, equation 4. Here you write them as equation. Here you write them as steps. Steps are different and equations are different carefully, okay? Now I think all these 4 equations are okay from step 1. Hello?
Okay, sir.
Yes. Now, step 2. Reduce the scope of negation. Please write it as it is. Reduce the scope of negation. Reduce the scope of negation. That means, in the starting of that FOL, if you find any negational sentences, you should reduce it. Here I have the reduce, so I can multiply it as, in the previous example, we have written it as negation of there exist. Can be written as for all X. Can I write this statement in this way? Hello? Can I write this equation for negation of there exist? Can be written as for all X. Yes or no? In the previous example, we have done it.
Yes, sir, we can.
Yes, sir. We can write so.
Now, first 3 statements, there are no negations initially, so directly we can copy. Okay, please write as it is. First 3 statements, copy to second step, and this statement you please write it as negation of there exist can be converted into for all X, and this negation will go inside. Then it will become negation of smiling X. Is it okay? Now this is step 2. I will give it 2 minutes time. Please take it as it is. Shall I go? Don't write it like me, okay? Don't write it like me. You should write copy the first 3 equations into step 2. Don't follow me like this. It's a blunder mistake. I have done it here.
Sir, could you scroll it up one, sir?
Yes, yes. Up here.
Yes. Yes, sir. Step
Yes,
one.
please, please. I think you have the statements with you from step 1.
Yes, sir.
Then I don't have any problem, even if we wait another 15 to 20 minutes time. But everyone should get the knowledge. If I give you any new problem, you should be in a position to solve it. Okay. Now shall I move?
Yes, sir, you can.
Yes. Now third step is standardize variables apart. Now we should standardize the variables. Okay. Now, actually speaking, here all these variables are standardized. There is no issue of changing anything. Okay. Now, observe carefully. All the variables are standardized. So I'm not touching anything. For algorithm purpose, I have given this step. Okay. Third step is if any variables are not standardized, you should convert it. I will discuss this step in another example. Okay. In unification problem. Okay. For time being, you please take it as it is. Now here what I have done is, now previous statement, all the statements we have represented as X. Now in the standardization process, what we are doing is in every sentence we are going to write a different variables. Now here, if you observe the first statement, here we have written as for all X, graduating X and happy of X. In the second statement, I have written as for every Y, happy Y, smiley Y. For every there exists Z, graduation of Z. Then for every W, smiling W. Okay, this is nothing but we are standardizing the variables. Okay, please do it. Remaining things I am not changing. Only variables only I am changing. Okay, earlier everything we have represented as X. In every equation, you should change the variables. I think for you, mostly they are not asking any external examples. Okay, they are asking how to uh, uh, explain resolution and predicate logic like that. Okay, what are the algorithm for writing predicate logic? Okay, now shall I move to the step 4? Hello.
Yes, sir. Yes, sir.
Yes, shall I move to step 4? Now, step 4 is move all quantifiers to the left. If you observe the statement, there are so many quantifiers in between. Okay, you should move all the quantifiers to the left side. If there are at left side, there is no issue of changing. Okay, here step 4 is moving all quantifiers to the left. If you observe the statements 3, all the quantifiers, if they are for all and there exist, has to be at left side. Is it okay? I think there is no need of any changing in the statement 4. Is it okay? I think all the quantifiers are at left side only. If you observe the statements, yes or no? Hello?
Yes, sir.
Yes, yes. But as a part of algorithm, you should write this statement. Step 4 is move all quantifiers to the left and simply put arrow symbol. Okay. Copy the 4 equations to step 4. Okay. Clear? There is nothing to do with step 4. Okay. Shall I go to step 5? Can I go?
Yes, sir.
Yes. Now, step 5, elimination of there exists symbol. Okay, elimination of there exists symbol, that we call them as columnization. Okay, we can use the names. Okay, here where you have there exists symbol, there exists symbol you have in the equation 3. Is it okay? Hello, hello. In harm sentences you can, hello, here how to now. Can I replace this z with a universal quantifier? Universally, can I replace with z with I don't know who is graduating. Okay, so I can replace with name. I don't know, with a person or a name. Okay, simply here we are writing, we are eliminating. Observe carefully, please observe. I can remove there exists z, and wherever z is there, I am replacing with either a name or a person name. Is it okay? You can replace it as a person. A person can be a lady or it can be a gent. Okay. Here, name one is the colonization constant, and nothing to worry with 1 to 4 statements. They already have universal quantification. Okay, no need to change it. Step 4. Is it okay? Please take step 4. Elimination of there exists symbol. Only in step 3 you have there exists symbol. So we have eliminated there exists symbol and we replace z with name 1. Here name 1 is called as colonization constant. And please copy the steps 1, 2 and 4 as it is. In step 6 we will try to eliminate the for all. Shall I go? Shall I go?
Yes, sir.
Please. Now, how to eliminate universal quantifier? Hello? How to eliminate this universal quantifier? What is the equation we have? Now, can I replace this x? Can I replace this y? Can I replace this w? That's nothing but. Now, what is the rule we have to follow in universal elimination? I have to replace that x, z, w with some variables now. Hello? Hello?
Yes, sir.
Now, if we want, now for example, if I don't know, in my problem statement, they have not at all given any constants. Did they given any constants to you in this example? Did they given any constant? All people graduating, all happy people. Okay. So I don't know. Please observe carefully. If I don't know, here I don't know, in my knowledge base, they have not specified who are graduating and who are happy people. Okay. If at any one sentence, if they give some Tom or Laika or Jim, I can replace that X or Z or W with that name. Here I don't know. So I should keep the same variables. Okay. Now, if you have any questions, you please ask me now. Okay. Here I am dropping for all. I'm dropping for all. And actually speaking, if my knowledge base has any name, okay. Now, did they given any names in the knowledge base? Hello? Did they given any names in the knowledge base? Any variables like Jim, that Sachin, Rahul? Did they given any names for
No, sir.
graduating? Not given now.
No,
So you cannot replace. So simply drop the universal quantification and put it same. Okay. We will replace them in the form of resolution. Okay. Drop the all universal quantifiers. If they have given any names, you are going to replace x Y and W with that name. Okay, please make it fast. Now we'll start the resolution process. Now I'll ask one question. Do your FOL consisting of universal quantifiers? Does your FOL consisting of existential quantifiers? Does your FOL consisting of implications? Are you getting me? That means your statements are elimination of universal elimination, and there exist elimination and implication eliminations. Now you are ready to start the procedure for disproving. Now, can I go to the disprove this statement? Now, my input is this one. Now, from the statements, directly we can disprove it. Shall I start resolution?
Yes, sir.
Now, could you please tell me, I have three statements, statement 1, statement 2, statement 3. Now, which is the opposite of the statement? Negation of smiling. Can I take statement 2, or can I take statement 1, or can I take statement 3 for disproving resolution? Resolution, you know, you have solved two problems. You should take this statement to disprove this statement. I should take statement 2. Hello?
Yes, sir. Statement 2.
You write it as statement 2. Here, I have considered my input to be proved as negation of smiling, and I have to consider statement 2. So, my statement 2 consisting of negation of happy or smiling of Y. Now, here I am using unification process. Unification, wherever Y is there, I am replacing with W. Are you getting me? Wherever Y is there, I am replacing with W. So now my smiling will be striked out with negation of smiling. Okay. Now what will be come down? Negation of happy of Y will come down. Is it okay? Hello?
Okay, sir.
Please take this step. Step by step we will go. Okay, and here you please write it as, this is called as unification process. Replacing Y with W. Please write it in your words. Here, replace Y with W. This process is known as unification. If you don't understand about unification, you write it as substitution. Okay. Now, shall I go to the next one? Hello?
Yes, sir.
Now I have negation of happy. Negation of happy I have. Now, can I take the statement 1 for disprove the statement? Can I take the statement 1? What is alternative to happy? Negation of happy. Can I take this statement? Yes or no?
Yes, sir.
Yes. Now, to disprove the negation of happy, I am taking statement 1. My statement 1 consisting of negation of graduating of X or happy of X. Now, I will strike it out. Negation of happy of W with happy of X by using unification process. By replacing X with W, I can strike it out. Happy of X with negation of happy of X. Now, which one will come down? Negation of graduating of X will come down. Is it okay? Hello? Please take this statement. Here we are replacing X with W. Now I have already completed statement 1 and statement 2. The only sentence left over with me is graduating of X. So now what I am doing is, I am striking out negation of graduating of X, and I am considering statement 3, graduating of name 1. Now the unification process is, I am replacing W with name 1. Now ultimately I got null class. Please take this. Ultimately, I got null class. Now, here you should write a simple state, otherwise you will not get marks. What you have taken as input and what you have proved it. So, we got null class. Now, can I call as someone is smiling? Is it true? Hello? Hello?
Yes, sir.
Now, you should disprove it, please. Here you have taken negation of smiling, okay? What you have taken is nobody is smiling. Here you have taken. And you are saying that somebody is smiling. It is wrong. You have proved it as wrong. So you are sure you write you have to write the statement at the end. Okay. So negation of smiling is has shown as null clause. So somebody is smiling is true. You should write this statement. You should write this problem statement, and you should say it as is someone is smiling is true. Okay. The conclusion has been proved. Okay. Is someone is smiling. Here we have a question mark. You should show that it is true. Okay. Yes or no? That we have disproved with resolution concept. Clear? You should write that statement. Otherwise, some marks will go out. Once if it is okay for everyone, now you have to, now another 15 minutes is there. I will give you a simple example that you already know. Okay, that example you should solve it. Shall I go? Shall I go to that statement?
Yes, sir.
Now, I will give you one more problem. You have to solve it. That you already know the problem. Okay. Please give me a minute. Let me open the document. Please give me a minute. Please take this sentence and you implement this example with resolution and first order logic. Please take these sentences. Is it visible? Please take the first 4 sentences. Is it visible? Please take the first 4 as 4 sentences, and you please take this 5 and 6 are proving, okay, using resolution in first order logic. You already know these statements. Make it first. Mammals drink milk. Man is a mortal. Man is a mammal. Tom is a man. Okay, and I need you to disprove these 2 statements. Tom drinks milk and Tom is mortal using resolution with the first order logic. You have to do it by yourself. And kindly submit, after completion of this, kindly submit it to my WhatsApp group. Okay. Kindly submit the answer to me within an hour. Okay. After the classes.
Okay.
Yeah. Please take the statement and do it. Now you start doing. Now next 10 minutes the time is there. Every day I am teaching, and now you please take care of it. First convert the sentences into FOL. Everyone, convert the sentences in the FOL. I need everybody has to participate. Regularly I'm doing examples. Now only one time I'm asking you to solve it. Everyone started? Hello?
Yes, sir. Started.
Please start it and follow my steps. I have given six steps to solve it. Please do according to my problem itself. Anyone completed the first step, conversion of sentences into FOL? Otherwise, we'll go step by step. Anyone completed mammals drink milk? Hello? Statement by statement, you should do it. Can anyone tell me what is the FOL for statement 1? Can I get answer from you? Those who have completed conversion of these sentences into FOL. If anyone completed, you please share it into my WhatsApp group. I will put it in that as a PPT. Later we will discuss it. Anyone is doing? Hello?
They're doing it, sir.
Yes, yes. So how much time it will take to convert the sentences into FOL? It's a matter of 2 minutes. You will not get pain if we take the examples. Okay, take another 6 to 7 minutes. Now that today's time will go out for the exam. Anyone completed the FOL statements? I did not get any response to my WhatsApp group. Hello? Yeah, wait a minute. I'm getting call. Hello? Otherwise, will you solve after the class and send it to me by afternoon? Hello? Yeah.
Okay.
Yeah.
Okay.
Yeah. You please by afternoon you will going to complete your classes by 12:30, na?
Yes, sir.
Now, can I get the answers by afternoon? Otherwise, I will solve the problem and I will put it in that group. Okay.
Okay, sir.
Okay. Now. Okay. Now, if anyone has any doubts, please ask me. If not, we will close the class. Any doubts till now? Now, only two topics are left over in unit number 2. That is, unification is one problem, and another problem is forward chaining and backward chaining. Okay. Now, those two topics I will complete by next week. Now, I don't know whether what other people are doing. Now, can anyone tell me how the assignments are given to you? Any other faculty are giving assignments to you, either in the form of quizzes or in the form of assignments?
They're uploading in the Google Classroom, sir.
Yes, yes. Okay. Are they giving quizzes or assignments directly problem solutions?
Only assignment questions will be given.
Okay. I think theory. Okay. I think are they giving it for marks? Any kind of marks? Does it carry any marks?
We don't know, sir. Actually, quiz contains marks, sir, but we
Okay.
don't know
Okay.
about the assignment.
Yes. Okay. Now I'll go to HOD and I'll ask her, and based on that, for every unit, your people will get 2 quizzes. Maybe this Sunday I'm going to put. Now I don't want. Shall I open the quiz for second unit first, because we have completed leisure till now. Na? We will have 2 quizzes in unit number 2. After that, we will go for 2 quizzes in unit number 1. Okay. Now, if anyone has any doubts in the unit number 2 till now, you can ask me. I will be available for the next few minutes.